Hi, I'm Andy, and this is my lesson on the object class in Java. In this lesson, I'll discuss a few methods in that class and how to override them in your own classes. Let's get started. In the previous lessons, we introduced 4 classes that can be used to make an online store application. This inheritance diagram shows how those classes are related to each other. As you can see, the store item class is the root of our inheritance tree and does not extend any other class. With that in mind, let me show you something surprising. Over in main, let's make 2 store item objects that contain the exact same data. Then we'll invoke the equals method on the first store item and have it check for equality with the second store item. Okay, so 2 unexpected things happened here. First, the equals method did not produce an error. That's surprising because, as you can see, there is no equals method defined in the store item class. And since the store item class does not extend any other class, it seems like it doesn't have a parent from which it could inherit that method. The second interesting thing to notice is that the equals method returned false, even though the 2 store items being compared are clearly equal to each other. So the questions are, why can we invoke the equals method on a store item object, and why does it produce such an unexpected result? To understand the answer to both questions, you need to realize this one very important feature in Java. Classes that don't explicitly extend another class automatically extend a class called object. That means all classes you make have a superclass, either the one you put after the extends keyword like in the book class, or object if you don't put the extends keyword like in the store item class. So the class hierarchy for this project, which we thought looked like this, is actually this. And in fact, all class hierarchies have the object class as their root node. That means, according to the rules of polymorphism, we can declare a reference to any type of object to be an object reference. That also means that all classes inherit objects, methods, and instance variables. So all these methods listed here for the object class can be invoked on any object of any type. And notice that one of those object methods is an equals method. That's why invoking the equals method on our store item did not produce a compilation error. The equals method in the object class only returns true if the 2 references, the one the method is invoked on and the one passed as an actual parameter, reference the same object. In our code here, we've created 2 separate objects, albeit with the same data. The equals method in the object class always returns false when comparing 2 separate objects. To see what I mean, let's change our code just a bit so that both references actually refer to the same store item object. Now the equals method returns true, because item 1 and item 2 are aliases for the same object. So that's the default behavior of the equals method, but that's probably not how we'd like it to work. Instead, we'd like the equals method to return true as long as the objects have the same ID, what we called the SKU when we created the store item class. Remember, we can change the behavior of any inherited method by overriding it. Let's do that by copying the method's header from the API. And then we'll add the @override annotation and that method header to our store item class. By overriding equals in the store item class, all of its subclasses will also use this new version, so we won't need to override this method anywhere else in our class hierarchy. Notice that the parameter in this method has a class type of object. This is an example of polymorphism. Since all classes have the object class as a parent, or a grandparent, or a great-grandparent, and so on, all objects we create can be referred to using an object reference. So by putting object as the parameter's class type, any type of object belonging to any class can be passed in this method. This makes the equals method as general as possible. You can pass pretty much anything to it and it will give you an accurate answer. Now in the method body, we'll use the instance of keyword to check to make sure that the passed object is an actual store item object. If not, we need to immediately exit the method and return false. Now we'll check to see if the store item SKU matches the passed object SKU. Notice we need to cast obj to a store item here, since the compiler won't let us invoke the getSKU method on an object reference. Okay, let's test this out over in main by making several more objects. We'll first make a third store item object, but give it different data than the first two. We'll then make a fourth store item reference, but this one will be a null pointer. Lastly, we'll make a string object. Then we'll use a series of print statements to see what happens when we invoke equals on item 1 and compare it to each of the other 4 references. Obviously, we want this first statement to produce true and all the rest to produce false. Let's see what happens. Good, so we got exactly the results we wanted, and didn't get any compilation errors or runtime exceptions. Without that initial instance of block of code, either of these two lines would have produced exceptions, because we'd be invoking getSKU on either a string object or a null pointer. Before going, let's make one very minor tweak to our store item class. Notice that the object class also has a toString method. That's why we can invoke the toString method on any object we create, no matter its class type. But you may also remember from previous lessons that the implementation of this method in the object class is not particularly useful. That's why we typically override the toString method in our own classes to do something more useful. And remember, we already did that for the store item class, right here. So now that we know that this class actually extends the object class, and therefore this is an overridden method, we should probably add the @override annotation here. The object class has quite a few other methods you may want to explore as you become a more experienced Java programmer. But for a beginning programmer, you really only need to be familiar with the two covered in this lesson, equals and toString. And that wraps up this lesson on the object class in Java. I'm Andy. Thanks for watching and coding with me today.